We're going to spend a couple days talking about section 6.5. So 6.5 is on radical equations and rational exponent equations. So this video is going to focus strictly on equations that involve square roots. So what a radical equation means is anything that is an equation, which again has an equal sign, that has a variable, and it has something under the radical, or it has a variable that has a rational exponent. So these are going to be ones that have things like the square root of x plus 5, and then an equal sign, and then some sort of number over there. That's called a radical equation. The directions for a radical equation will say to solve. The goal is to figure out what value or values of x make it true. So I have the steps here listed, and this is a nice checklist to kind of reference throughout the entire section. So your first step in solving a radical expression or equation is to isolate what has the radical. So wherever the radical is, have that be the only thing that is on the one side of the equal sign. And that's going to involve adding, subtracting, multiplying, or dividing. Next step is to eliminate the radical by taking both sides to the reciprocal power. So we're going to do a lot of square roots to start. If I want to get rid of a square root, I have to square it. So I'm going to do the reciprocal power, or the opposite operation. And then my last step is to get x by itself. And then you can check your answer very nicely by just plugging it in and make sure it makes it true. So we're going to do 4 examples in this video that are what I would consider basic, or Delta Math calls them level 1 radical equations. So what you'll notice with all of these is all of these have some sort of radical that has a variable under it, has an equal sign. The goal is to solve. So our first step is to isolate the radical. So in this first one, I'm going to isolate by subtracting 3. So I have the square root of 2x minus 3 equals 5. Now I have the square root that I need to get rid of, so I'm going to square both sides. I like putting in parentheses to show it. So 2x minus 3 is what you get when the square and the square root cancel, and then 5 squared is 25. And then we want to finish by solving. You'll be left with something very simple to solve. So 2x equals 28 when I add 3, and then x equals 14 when I divide by 2. And to check and make sure that that's actually right, you can very quickly check it. You don't have to actually show this step, but you can do it in your head with a calculator. You're going to put that 14 back in for x and make sure it makes both sides of the equation true. So my next one, to isolate, I'm going to add 5 to both sides. That will move that. That will isolate the square root of 4x plus 1. I'm at the same point as I was in the last one when it's time to square both sides to get rid of the square root. So the square and square root cancel. I'm left with 4x plus 1 equals, again, 25. Subtract 1 to get the plus 1 to move, and then finally divide by 4. So my solution for this one is 6. And again, I can plug 6 right here to make sure that both sides are equal to the same value to check your answer. Next one has an addition to start, so we're going to add 2 to both sides to isolate the square root. Get rid of the square root by squaring both sides. So I have 6 minus 3x equals 2 squared is 4. Subtract 6. So I get negative 3x equals negative 2. And then finally divide by negative 3. And you will get answers that aren't always integers. This one ends up being a fraction, 2/3. You can still check it the same way by putting that 2/3 back into my original equation to make sure both sides are equal. My last one has an extra step in the beginning to isolate, so I'm going to start still by adding 2. So I have 3, and then the square root of x plus 4 equals 21. The extra step in this one that wasn't in the previous 3 is you have to divide by 3 to get rid of that coefficient that's in front of the radical. So I have the square root of x plus 4 equals 21 divided by 3 is 7. Square both sides to get rid of the square root. So you're left with x plus 4 equals 7 squared is 49. And subtract 4. So my answer is that one is 45. And again, if I put 45 right here where the x is, I would see that both sides are equal to each other. So those are basic level 1 square roots. Isolate, square both sides, and then get the x by itself to get your answer.